Imagimob, subsidiary of Infineon, part of Infineon since 1.5 years. And we are looking into building machine learning models and enabling users to build their own machine learning models. And the focus of all of this is to have them as small as possible, to have the models have a really small footprint on the chips end. What comes with it automatically is low power consumption. So that's where we are aiming for. And today I have three amazing panelists with me, and I would like to spend a little bit of time for each and every one of you to give an introduction.
Okay, hello everyone. My name is Baichuan. I come from the Lund University, Sweden. I'm a PhD student, and my research focus is on the efficient training and efficient inference of AI models.
Hello, good afternoon. So my name is Eiman Kanjo. I'm a professor in TinyML, Edge AI. I work at Nottingham, Trent University and Imperial College London in UK. I've been working in this area for a long time, and I have upcoming role in leading TinyML UK to advance TinyML and Edge AI innovation in UK as well.
Great. It's Pete Bernard, CEO of the Edge AI Foundation. We're the world's largest community of Edge AI developers, technology providers, and academia. And worked with Professor Kanjo for a while and Infineon as well. So yeah, it's great to be here. It's great to see so many topics around Edge AI at the show.
Perfect. Thanks to all of you to be here. And yeah, so when I read a little bit into this, I have no deep IT and machine learning background, but in my preparations, I found a few cornerstones of Edge AI, and deep learning is probably one of them. Maybe, Baichuan, you can start to give us a little bit of a roundup. What does it mean? What does it contain?
So first, I think that nowadays that AI model is all over the world, and the Edge AI aims to deploy the AI model into the IoT devices, and also in the academic perspective, I think how to make the AI model can evaluate as the time going is also important. So we need to fine tune the AI model on the edge devices. I think that's the main constraint or the limitation in the edge AI domain nowadays, at least in the academic perspective. Yeah.
Oh, sorry. Was it like what is the
The cornerstones of Edge AI and
deep learning in particular? Yeah, I mean, deep learning is not the only thing that you could do when it comes to Edge AI. So there are many other techniques, and I know some other innovative SMEs or startups now looking at, like, for example, logic or other type of techniques. But deep learning in particular has been tested for a long time, and that's why everybody tries to optimize these models as much as possible. And whenever you talk to someone about Edge AI, I was in an event yesterday about Edge AI in the UK, and every single talk is talking about quantization, pruning, and they say, okay, try something else. But yeah, I mean, at the end of the day, when you get this model, you want it to fit on a very small device, like when you try to pack your suit, you know, you try to push everything inside, and it doesn't work, and I end up like ruining everything. But you have to try to optimize that model, and you keep quantizing until you get into binary network and so on. I don't think there's a limit. I've discovered that there's always a way where you can keep optimizing until the model disappears all completely.
There's always a way to stuff that suitcase. Yeah, I mean, I like to use the phrase efficiency is the new currency, in AI. So all of the innovation that's happening in this space, I think the frontier is just about efficiency. And, I mean, DeepSeek was one example in sort of, large language models where, innovating in the resources used is super valuable. And I think that goes all the way down into the IoT space as well. So we're starting to see, small language models, or what they call crazy small language models, getting into edge equipment, agentic AI getting into edge equipment, more at the MPU level, but even at the MCU level and even below, we're starting to see some amazing horsepower, I would say, around AI models and a lot of innovation. So the efficiency part is kind of that is the thing, that is the currency.
Thank you, Pete. Professor Eiman, Baichuan has talked about with me earlier about backpropagation, so I've learned a lot about edge AI. I know you're looking into decentralization of in edge AI. Can you help me to understand and?
Yeah, I mean, I started my research as I said, for many years, like technically trying to develop edge AI solutions. Started as IoT, wireless sensing, but then now this is turning into a movement rather than just the technical development. And the reason for that, I mean, like for example, in the last few days, we had a few announcements in the UK about new deals with NVIDIA, OpenAI, Google, and all the big tech giants setting up data centers that cost billions. And which is great, like everybody is excited. We're going to have our resources to be able to compute and run these models locally, but still we are very much connected to these organizations. And then you ask the question, do you really need these data centers every time? I mean, we had some cases where the government comes to our local authorities and say, we have some money. Go and find people who can use these data centers. We will give you millions, but find the customers and say, okay, it doesn't work like this. Like you might set up a very expensive data center, but you might not need it. So why not ask the question, like, when do I need these computational resources? So the decentralization is all about that we need to think about this model. Do we need really large model? And do we need these computational resources? If you are, for example, running, I do the morning run every Saturday in Nottingham, I might not need these large models. I don't need all the knowledge in the world to be on my device, right? I might need just a few local knowledge, and these are much, much less in terms of the size of the parameters and so on. So why do we force all of us, force everybody to use these data centers, the centralized approaches and so on, when we can do it, sometimes. I'm not saying we should do everything in a decentralized fashion. There are times, like for example, we have to share data and so on for like foundational models development and so on. But we need to ask the question, can we do this at a local level? Can we minimize the size of the model, or do we really need this large model? Can we do some kind of adaptation and so on? And that's where we need to, and then of course you reduce power, you reduce latency, and privacy is the most important part of that. So that's why decentralization is important.
Just to kind of amplify that, I mean, I think the default posture should be you're running AI models where the data is created. That's the default. Yeah. And then, again, if it makes sense to have it processing in the cloud, yeah, you should use the cloud. But I think a lot of folks default to the cloud. And I think, you get into this interesting cycle where you build like Stargate, whatever the thing is, and then, okay, now you got to use it. And really, about 75% of all data is created at the edge. I think that's what Gartner said. And so, okay, so 75% of all AI workloads should be run at the edge. And then we should only do 25% in the cloud. But, I think that's kind of where we're heading. We're not there yet, but.
Thank you. And now, Pete, maybe directly back to you. We have two great minds from the academia here. I would love to hear your take on the innovations which really were essential to be able to have low-powered embedded devices with those edge capabilities like we see them today. And maybe I would love to hear all of you.
Yeah, I mean, one of the cool things about the foundation is we have a strong academic component, and anytime we have events or symposiums or live streams, we always are interested in the research from PhD students and other folks that are pushing the envelope. Not all of it's commercializable, but it does push the envelope. It enables people to stuff more into their suitcase in some cases. So I think it's really critical to nurture that. We do see a lot of folks from academia, frankly, spinning out some interesting startups as well. That's happening on a pretty regular basis. or providing consulting of tech companies and how to do this stuff. So I just couldn't imagine Edge AI wouldn't be here without the academic investments. I mean,
just to give you an example, so yesterday I was at an event again by Defense UK, and all the speakers were from industry, and I was almost the only one from academia. But then you see how industry speakers didn't want to give too much about their products, and I was like, there, take all this knowledge. I was like talking about everything, because we, as academics, you know, we like to share knowledge. I'm not saying industry don't, but you know, they have IPs, they have a commercial plan, and so on. Where academics, I mean, like someone told me yesterday, every time you come, you have different type of presentation, and then you, I don't know what happened to the previous talk. I mean, what happened to the development? And that's the academic mind. You know, like you find something interesting, you find new innovation, and you start to adopt that. And then I might talk about this today. I might talk about something else later. But if you are coming from industry perspectives, this is difficult. You can't just jump from one topic to another. And that's why we need both. Like in, you know, with Edge AI Foundation, we have this kind of mix where people come and innovate at a larger scale, come up with good, bad ideas sometimes. But then you have industry to bring us back to the reality that, oh, this needs to be turned into a product, who's going to be the customers, and so on. So the interaction between the two worlds is very important.
Yeah, I also agree. I think I have listened to a postdoc from Feifei Li, and she said that nowadays the PhD study in, especially in computer science or AI model, is different because nowadays the lots of computing resources and the data resources are owned in the big tech company like Google, Meta, or something. So in academic, I think as PhD students, you need to find some interesting problem that let's avoid the lots of the need for the computing resources. So that's a kind of compensation for that. So yeah, that's what I'm thinking.
Nice, thank you. And I just had to look it up again, Baichuan. Your field is bio-inspired deep learning. Very, very interesting. It sounds great. And I mentioned it earlier that we had a discussion about backpropagation. Maybe you can help me again to understand a little bit about what it is and how we could potentially use it for low-powered systems in the future.
Yeah, okay, yeah. So nowadays everyone is talking about AI and deep learning model. So I would say 99.9% of the AI model are trained or fine-tuned by the backpropagation. This algorithm is proposed by a master student from Finland, but later on is used by the George Hinton in the neural network. So, but nowadays the backpropagation has some problems because now we have the large language models from maybe 100 or 200 million parameters to even like several billion parameters. So if you want to train or even fine-tune the models, not all the parameters, even some parameters, you need even 2 to 4 times of the memory compared to the parameter itself, because you need to store the activation, the gradient. So in my understanding is nowadays, especially for the edge AI models, if you still use the backpropagation to fine-tune the models, maybe it's not possible. So let's take an example. If you do an inference for large language models, maybe it's only need let's say 1 megabytes memory. But if you want to do the fine-tuning, you need maybe 10 megabytes. So if we can fine-tune the model only with the comparable memory consumption as the inference, then it's a big relief to the edge AI models. I could say nowadays there are some top AI conference. They have some potential to solve this problem, like zeroth order gradient calculation, or only to the direct technology to make the AI models or large language model to be compatible, deployed on the edge. So I would say that's one potential research topic to be relieve these constraints. Yeah, thank you.
I just realized again that I think I have to enroll myself for a summer school to get up and running with your knowledge. Thank you for that. I think we have a lot of great things out in the field, and maybe since we come close to the end, maybe we can have a last round of your take on how we could make those low-powered embedded edge AI technologies we are seeing right now more accessible to a wider audience and more accessible to the big mass. Pete.
Well, I mean, going back to Professor Kanjo's note about academia, there's a ton of opportunity out there to learn new things. We have, if you go to edgeaifoundation.org/learn, we have a whole collection of resources for people to dig into, whether it's online courses. We have career development live stream we do for folks, and we have Edge AI challenges and contests and things going on. So I think it's a pretty frictionless environment for people to learn more about how to do this stuff and to kind of get involved. So I think that's a good thing.
Yeah, I mean, and beside that, I mean, we need to be open-minded when it comes to the development of Edge AI and how it evolves. Even Edge AI, it was TinyML and then Edge AI, and God knows what will it be in the next few years, because you can't just stay still, and you need to see what's happening. Like, for example, we are here at the Things conference, which is not just about Edge AI, but also communication, low power, and so on. So some of my work looks at connecting these devices together. It's not just about one device, and how can you share resources, for example, and how can you use low power, low energy, low cost connectivity between them and create a bigger pool of resources that we can tap into. So there are a lot of opportunities. It's just that we need to be mindful that technology doesn't stay still, and we could always optimize it, as I said before.
Sorry, what's the problem? What's the question?
How we can make low-power Edge AI devices more accessible for the bigger market, for the bigger audience, wider audience.
Yeah, okay, that's an interesting question. I think, yeah, I mean, for me, every day I just stay in the lab and do some research, right? So I'm thinking that, yes, maybe, yeah, I mean, we can, for us PhD students, we can make our research results to be accessible to more audience in a simple way, not the very high technical, I mean, very simple words to introduce what we have done and what can we make some difference to their life. And if they want to make the change, they maybe seek the help from us. Then we can make the profit. Yeah.
That will for sure help me. Yeah, maybe one last question for the round. In just like a few words, what excites you most about the next 2 to 3 years in Edge AI?
Yes, from my point of view is efficient training and inference of the AI model. Because I think nowadays the Silicon Valley, especially the machine learning and system domain of this, are talking about how to speed up the inference of the large language model. So in my opinion, is how to make this one become very accessible to all of the people to help their life is important, like efficient inference and training, yes.
There's the concept of contextual AI, which I hope it will pick up, and it can only work with Edge AI embedded devices. Contextual AI is all about devices sensing and processing data and helping us doing everyday tasks. At the moment, large models are more accessible from big machines or like from desktops and so on, sometimes in your mobile phone. But what is exciting to see them out, like you have some models that, or generative models running sensor data in smart home for healthy aging and these kinds of applications. So contextual AI is what would make Edge AI useful for different types of communities.
Yeah, I like that term contextual AI. I think the kind of mashup of language models with sensor data over the next few years, and now as platforms become more capable, and we have a generative Edge AI, an agentic Edge AI working group at the foundation. We're actually doing a 2-day live stream in November, so if you come to our website, you can listen to like 2 days worth of tech talks on how language models, small language models, and agentic AI are making their way to the edge. So I think that's kind of inevitable. We'll see some horrifically stupid implementations, talking refrigerators and stuff. But then we'll also see some really cool stuff too, like aging in place and healthcare and things like that too. So.
The talking kettle.
The talking kettle, yeah.
I think I will dial in for that. And yeah, with that, thank you all for coming. Especially thank you to the panelists, Eiman, Pete, Baichuan. Thank you for being here.